This video will discuss Chapter 8.10, Systems of Equations. So we're only going to really talk about two different ways to solve systems of equations, and there are multiple ways to solve them. And so we're going to use this problem and solve this two different ways. So the first way is to actually graph it. I'm going to show you a picture of what it would look like to graph it, but before we do, let's make sure we understand y equals mx plus b. And remember, this is also in that form, y equals m, there's a number in front of that x, mx plus b. So if there's nothing there, that's a 0. So the slope of this line is 1, the y-intercept is 0. The slope of this line is negative 3, the y-intercept is 4. And so if you are going to graph it, and take a look at the book as they graphed it, you can see that for that first line, slope, the y-intercept is 0. I'm going up 1 over 1, up 1 over 1. You would create that line. And then for this one, I'm going to go up to 4, 1, 2, 3, 4. And then I'm going down 3 over 1, down 3 over 1, and then you would have that line. Okay, and then what I'm looking for is where do these two lines intersect? So the idea with systems of equations is, what is the point of intersection for these two lines? All right, and so coming back to this, if I'm now thinking about, okay, what is the point of intersection of these two lines? Basically, when does this line equal this line? What I want to do is, since they're both in y equals mx plus b form, I'm essentially going to take this and substitute it in to this y. So if y equals x, then that means that this y would also equal x, which means that x equals negative 3x plus 4. So the reason it's called substitution is, since y equals x, I'm going to take x, I'm going to substitute it in there for y. Now to solve this, I would need to add 3x to both sides. This will cancel out. I'm left with 4x equals 4. And then I'm going to divide both sides by 4. And I've got x equals 1. Now keep in mind, my answer needs to be in the form of a point on the graph, since I'm looking for the point of intersection, which means x is 1. Now I need to figure out what y is. There's a couple ways to do it. The easiest way would be to take this 1, substitute it into there, and I know that y equals 1. Or I could substitute it into here. Y equals negative 3 times 1, so that's negative 3 plus 4, or negative 3 plus 4 is 1. Either way, I should get that y equals 1, which means my point of intersection should be 1, comma 1. Right, so you can either see that through substitution, or if you were to take the problem and graph it, you could see it on the graph that they actually intersect. So I get you closer. They will intersect at 1, 1. All right. Now let's try another one. This time we're going to do this without graphing, simply using substitution. Y equals 3x. Y equals x plus 12. Since I know that y equals 3x, I know that y equals x plus 12. I'm going to take this 3x. I'm going to substitute it in for y. So I've got 3x equals x plus 12. All right, from there I can subtract x from both sides. Cancels out, so I've got 2x equals 12. And then from there, I'm going to divide both sides by 2, and I've got that x is 6. Now, I know what my x is. The question is, what is y? So I'm going to take that 6 and I can substitute it into either of these two equations. So I could either go y equals 3 times 6 and try to figure out what that is, or I could do y equals 6 plus 12. Either way, you should get an answer of 18. Right? You do not necessarily need to solve both of these ways, but one of these two should give you the answer of y is 18, sorry, and so this is going to be 6 and 18. So these two lines will intersect at the point 6, 18. All right, now let's talk about what happens when it doesn't work out quite so nice. So for example, a problem like this. Y equals negative x plus 1, y equals negative x minus 3. So one way would be to graph them, right, we go up to the y-intercept of 1, and then this is a slope of negative 1, so I'm going down 1 over 1, create my dots, right, and my points, connect the dots, and then here I got a negative 3 as my y-intercept, slope of negative 1, down 1 over 1, and then I could connect those dots, and I could figure out where they intersect. Or, since we've learned substitution, I'm now going to take this and I'm going to substitute it in for y. So this is negative x plus 1 equals negative x minus 3. So to get the x's on the same side, I'll add x to this side and add x to this side, and then of course, hopefully what you're going to see, or you realize what's coming next, is that 1 equals negative 3. So I got two problems here. First problem, of course, is that the variable is gone, so I no longer have an x, and then the second problem is that 1 does not equal negative 3. So if you get to this point, what this means, and you may be able to see it up here, is if two lines have the same slope, it means that they are parallel. Okay, and so since these two lines have the same slope and they are parallel lines, that means they will never intersect. So this line will never intersect with this line because it is parallel. So this we can just write as parallel lines. All right, and then a second problem that might come up is one like this, and since this is not in y equals mx plus b, let's try to get that into y equals mx plus b. So the first thing, so rewrite this. First thing I would do is add x to both sides. So this will cancel out. I'm left with 1/2 y equals, I'm going to write it as x plus 2 instead of 2 plus x because I want to have it y equals mx plus b. But I want to get rid of this 1/2, so I'm going to multiply both sides by 2. So I'm going to multiply this by 2, and then I'm going to multiply this by 2, keeping in mind that this is the distributive property. 2 times 1/2 is 1, so this is y equals 2x plus 4. So my two lines are this one and this one. Now you may notice something about that. Right? Y equals 2x plus 4, y equals 2x plus 4. They're the same line. Right? So these two lines will always intersect because one is on top of the other one, right? They're the exact same line. And so on this, you can just write same line. Right? So two mistakes that sometimes will pop up is that you will end up getting the same, and if you were to kind of take this further, you'd end up with 2x, right? If you hadn't noticed your mistake, so you hadn't noticed these were the same line, you would write 2x plus 4 equals 2x plus 4, right? And then you'd start trying to solve this. So then you would subtract 2x, let's hope, from both sides, right? And then these two would go away, and then you'd be left with 4 equals 4. So the good news, I guess the bad news is the x is gone. The good news is that 4 actually does equal 4, whereas in this problem, not only was the x gone, but we also had 1 equals negative 3, which is not a true statement. This one is a true statement. Right? 4 does equal 4, so if the statement is true and the variable is gone, that means that they're going to be the same line. So sometimes you may not necessarily notice that they're the same line before you start trying to solve it. However, if you see that this equation and this equation are exactly the same, you do not necessarily need to kind of go any further. You can identify that as the same line. All right, that's all I got for you on systems of equations. Keep in mind that the answer to a system of equations is a point on the graph. So it should be x comma y inside of parentheses. Make sure the x value comes first, even if you sometimes solve it second. However, in the examples we've shown you, you're probably usually solving for x first. So thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.